Hello, dear students. You're welcome to RK Institute. I am Dr. RK Seni. As you know, in previous class, I discussed E1 mechanism, and today I am going to discuss E2 mechanism. And these are the elimination reactions. For E2 mechanism, following conditions and following mechanism obeyed by the substrate. For example, if leaving group, first point, if leaving group and beta carbon contain H plus ion are opposite, anti to each other, then elimination E2 mechanism takes place. It is typical anti-elimination. It is typical anti-mechanism. Removal of proton by the use of base and removal of leaving group from the substrate are simultaneously takes place. Therefore, alkene character developed in the transition state. Alkene characters are developed in the transition state. Removal of leaving group and removal of proton are simultaneously takes place in E2 mechanism. In E2 mechanism. Typically anti-elimination, single step reaction, and after removal of the leaving group and deprotonation, the product is unsaturated hydrocarbon, namely alkene. After H and leaving group removal of. Therefore, following conditions for the substrate undergo E2 mechanism. First, leaving group, first essential condition, leaving group and beta carbon containing hydrogen are anti-position to each other. Second, base is sufficiently strong base. Leaving group is poor leaving group. Leaving group is poor. And the major product is formed according to stability of alkene. Major product depends upon the stability of alkene. Or we can say Saytzeff alkene. We know that Saytzeff alkenes are more stable and hence they are the major product of the reaction. For example, when cyclic secondary alkyl halide, for example, this cyclic alkyl halide, this is the CH3 and the Br, and this treated with alcoholic KOH. In alcoholic KOH, elimination of HX means removal of HBr from the substrate. Now we check bromine, Br and methyl are in same side. It means beta carbon contain H plus ion opposite to Br in this carbon and also that carbon. Therefore, two products are there. Therefore, in this mechanism, two products are there. First, this alkene, and second one is this alkene. The major product, this alkene. The major product is this because more stable alkene and removal of H and Br are opposite to each other, or we can say they are anti-position to each other. And hence this alkene is more stable due to more number of alpha H. Namely, 7 alpha H are there. 7 alpha hydrogen are there, more hyperconjugative structures and more stable. But in this alkene, only 3 alpha hydrogen are there. Therefore, it is less stable. And hence, this one is major and this one is minor alkene. But when same substrate, but different arrangement or orientation, when hydrogen and bromine are in same position, for example, the substrate is methyl and bromine are anti-position to each other, and then reaction with alcoholic KOH, then elimination of HBr also. But but hydrogen with respect to Br in that carbon atom is syn position. Therefore, it cannot be eliminated, and hence only it gives single product. Only it gives single product. Only. This is the E2 mechanism. Substrate secondary and check leaving group and beta carbon containing hydrogen are must be anti to each other. Then elimination takes place. Another question. Removal of bromine, yeah, halogenation vicinal dihalide. Vicinal dihalide is another example of E2 mechanism. For example, 2,3-dibromobutane treated with zinc dust, zinc copper couple, and on heating, or this reaction also produced by magnesium powder. On heating, they eliminate the substrate, eliminate Br2 and change into the alkene, particularly 2-butene. It is E2 mechanism, and the product another product are ZnBr2 or MgBr2. It is another example of E2 mechanism. The reaction proceeds via gaining of electron from zinc or metal during their oxidation. Zinc change into their ion and it loses 2 electrons due to presence of empty orbital. In case of bromine, it gain electron, change into anion, left their electron, and removal of the bromine from opposite position to each other, and hence alkene character are there. For in case of stereochemistry, E2 mechanism makes cis or trans alkene during the elimination of bromine. For example, we taken meso compound. For example, we taken meso 2,3-dibromobutane. Meso 2,3-dibromobutane in zinc dust. Then the alkene is 2-butene plus ZnBr2. To check stereochemistry, this Fischer projection formula is also eclipsed form. Fischer projection 2D or Fischer projection formula is eclipsed form. Therefore, we write eclipsed form of this compound. CH3 at front carbon contains CH3, H and Br. CH3, H and Br. And then we write their eclipsed form. H of hydrogen and H of hydrogen of second carbon are in eclipsed form. Br and Br are in eclipsed form. Methyl and methyl are in eclipsed form. This molecule rotate in such a way, therefore both leaving group are anti-position to each other. Therefore, front carbon remains constant. Front carbon remains constant, and the carbon of back carbon, their groups are rotated in such a way, therefore both leaving group are become anti-position to each other. Therefore, this group, this back carbon is rotated, by which this bromine at the anti-position of first. This bromine at the anti-position, this methyl become also anti-position. This methyl is also anti-position to methyl, and this hydrogen also anti-position to this hydrogen. And after removal of Br2, we write their structure. Therefore, this carbon, front carbon, contains CH3 upward and hydrogen downward. In below the carbon, your back carbon, hydrogen upward and methyl downward. Methyl downward. Therefore, this is the transalkene. This is the transalkene. Conclusion. It means, like as addition reaction, we know that CAR and TAM. It means reactant is meso. Reactant is meso means both eliminator present in same side in Fischer projection formula. Elimination anti, then they gives transalkene. Check the question. Similarly, and in case of addition, we write transalkene anti-addition, then product is meso. Now we read meso product anti-elimination, and the product is trans. Check the question. For example, in case of racemic mixture means both bromines are in opposite side in Fisher projection formula. Both bromines are in opposite sign in Fisher projection formula. Then it is optically active, and their another form is known as racemic form or D or L form. We write Eccleston form of the 2D structure of Fisher projection formula. In Eccleston form, front carbon contain methyl, hydrogen and bromine, and back carbon contain bromine in form of Eccleston form in H. In second, bromine and hydrogen are also in Eccleston form, and both methyl are also in Eccleston form. Now, molecule rotate in such a way by which both eliminator are just opposite or antiposition to each other, and then eliminate these. Therefore, the molecule rotate 120. The molecule rotate 120, or we can say 60 degree, not 120, 60 degree. This bromine at this position, 60 degree rotate. CH3, front carbon remains constant, and the bromine rotate only 60 degree. Therefore, back carbon at this position, this methyl at this position, and the hydrogen at this position. After removal of leaving group, means bromine, we write conformation of the alkene. Front carbon contains CH3 and hydrogen, and in back carbon, CH3 upward and hydrogen downward. This is the cis alkene. Therefore, CAR means racemic mixture. Both are opposite. Racemic mixture, anti-elimination, and the product is cis. Yes, it is the product of cis, and it is the stereochemistry of anti-elimination. Like as addition, we write elimination also. Another example for E2 mechanism. Another example for E2 mechanism. If following conditions in E2 mechanism, then incipient carbanion characters, incipient carbanion characters are developed in transition state. Transition state means in alkene. Therefore, the stability of alkene depends upon the carbanion. Therefore, the major product is Hofmann alkene. For example, if leaving group carry positive charge, for example, trialkylamine or dialkyl sulfur, such positively charged leaving groups, or leaving group is very poor leaving group. For example, fluorine is very poor leaving group, or the base is very bulky alkoxide ion, strong base. Then fission of CH bond is greater. Fission of CH bond is greater than the fission of leaving group from the alpha carbon. Therefore, transition state carry incipient carbanion character, and the major product is an alkene. For example, elimination in quaternary alkyl ammonium hydroxide. This is the quaternary alkyl. Ammonium. It is the quaternary alkyl ammonium hydroxide. On their heating, it eliminates tertiary amine and change into carbanion. Alpha carbon contain nitrogen. Suppose in left hand side, first we consider left side and side group. After removal of H plus ion, more replacement of H plus ion, this group carry partial negative charge or insufficient carbanionic character, and this carbanion is secondary type. After removal of H plus ion, this beta carbon is carry partially negatively charged, but this carbocation is secondary type and this carbocation is primary type. Therefore, we know that primary carbanion is more stable and hence this mechanism is preferred. Therefore, the major alkene is ethylene and water plus tertiary amine and dimethyl propylamine. And hence it is also E2 mechanism, but development of the insufficient carbanion character because the leaving group carry positive charge and by the positive charge it stabilize anion. Therefore, H plus ion remove fast or some more extent of carbon hydrogen bond than removal of leaving group from alpha carbon. Therefore, gives Hofmann alkene is major product. Hofmann alkene is major product. Hofmann alkene. Another example of Hofmann alkene. For example, alkyl fluoride, 2-fluorobutane, treated with alcoholic KOH. It is secondary alkyl halide and hence also E2 mechanism takes place, but the leaving group is very poor and hence carbon hydrogen bond fission faster than removal of leaving group. This is the beta carbon. After removal of H, the beta carbon carry negative charge. After removal of H, the beta carbon carry negative charge. But right hand side beta carbon gives primary carbanion and it is secondary carbanion, and we know that the stability of carbanion is primary, secondary and tertiary. Therefore, major product is 1 alkene. The major product is first butene. However, so second butene is also there, but the major product is Hofmann alkene if leaving group is very poor, like as in fluoride ion. Another example, in case of bulky base, for example, this substrate treated under sodium alkoxide. If sodium alkoxide is sodium ethoxide, it is secondary alkyl halide and hence E2 mechanism preferred. E2 mechanism, it gives two products, namely 1-butene and 2-butene, but it is the mechanism of E2 and the leaving group is neutral. Therefore, mainly alkene character are there. Simultaneously removal of H and leaving group. Therefore, the major alkene in this reaction, major, nearly 70% or more. However, first alkene is also there, but the major alkene is Saytzeff alkene in presence of sodium ethoxide. But when we taken bulky base like as sodium T-butoxide, sodium tertiary butoxide, then E2 mechanism, insufficient and anionic character, carbanion character in transition state, and we know that primary carbanion is more stable than tertiary carbanion. Therefore, the major product is Hofmann alkene in this case. Hofmann alkene is major product and Saytzeff alkene is minor product in presence of sodium T-butoxide. Sodium T-butoxide substrate is same, but we check different base. Sodium ethoxide is simple normal base, E2 mechanism with mainly carbanion, with mainly alkene character. But in sodium T-butoxide, it is very strong base. Therefore, removal of carbanion first, and according to stability of carbanion, major product is less stable alkene and is known as Hofmann alkene. Okay, and these are the examples of E2 mechanism. In next class, we further